So next we are going to see image reject receivers. So in image reject receivers, I am going to specifically do some operation to reject the image completely. So what I am going to do, I am going to take a signal and I am going to shift it by 90-degree phase. So if I am going to take cos omega t, it will become sin omega t. Whatever, if I am going to have an additional information phi of t, I am going to get the exact sine term plus that signal itself. So image reject receivers work on this principle. If my information is there in the phase, it will not get changed. How much ever shifting I am going to do by the signal. So this is the basic concept of image reject architecture. To summarize, if you have a positive frequency, I'm going to multiply by minus j. If I'm going to have a negative frequency, I'm going to multiply by plus j. So alternatively, I can write this in frequency domain. See, if you are multiplying by minus j and plus j, it is just like a signum function, which will be signum function has the same property. Positive values will be multiplied by a positive constant, negative by a negative constant. But here it is reversed. Positive multiplied by minus j, negative multiplied by plus j. So I'm writing it as minus j into signum function of omega. So I'm doing it everything in the frequency domain. So S, G, and W indicate a signum function, which is going to be the shifting by 90-degree operation. So shifting by 90 degree is equivalent to what? Multiplying by minus j into signum function. Definitely phase shifters we are implementing using uh, RC and CR networks. Either I'm going to use a low pass filter or I'm going to use a high pass filter. So the transfer function of low pass filter is given here. Transfer function of high pass filter also given here. So